has trade and continuous relationships with Venezuela since 10 years ago. We provide medical equipment of high technology to our clients, being pioneers in the acquisition of Cyberknife equipment for radiosurgery procedures across the Caribbean and Latin America. We count with a group of experienced and certified engineers by the different parent companies. This guarantees us the development of our projects in a physical and remote way.
Our radiosurgery unit started to function in 2012. Till this day, we've treated 402 patients who are divided in 374 patients with intracranial injuries and 28 with extracranial injuries. The advantage of having a Cyberknife above other equipments is that it can allow us to do the treatment without the needing of using a stereotaxic frame for the fixation of the patient with intracranial injuries. Only by placing an aquaplast mask, the patient is immobilized for the moment of receiving the treatment. We can personalize the kinds of treatments I give because we can give only one dose or we can hypofractionate the treatment. This can be given in 3, 5, and 8 doses. The advantages for our patients are that this is a high-precision equipment that provides important doses to the injuries that are going to be treated. It's used in intracranial injuries, and our main objective is a precision in the doses delivery because don't need masks or a stereotaxic frame, for instance. Because it's a treatment given robotically, it can adapt to the localizations of the intracranial injuries of the patient, so gives us extensive possibilities of treatments, among them the tumors as known, the arteriovenous malformations, and some other neurological and spiral column pathologies that we can treat.
First, we start with the import of the images that can be a computerized tomography, being the primary, and a nuclear magnetic resonance. These two images are merged, and then the medical part make a contouring of the injury or the GTV. Then we make the alignment of the treatment where we create the RDA, and therefore is made the treatment plan, that can be 3 ways. The first, the isocentric way, where all the aces converge, and the second can be the conformed isocentric way. And the last one, and more recommended and efficient to use with this system, is the non-isocentric. After making the planification, we verified it, and then we observe and check the doses at risk organs, the isodose curves, and the dose volume histograms. Once this is all verified, it's held a meeting with the doctor to check out if the treatment plan is acceptable or not. After that, the patient goes to the work area where it's going to be applied by the radiologic technician. I'm gonna talk to you a bit about one of the relevant aspects, or the characteristic, of the Cyberknife equipment in contrast with other administration radiation systems. For example, one of these are the tracking system. One of these tracking systems, used in a global way, is the imaging system, independently of the kinds of tracking for the objective or injury, being this a tumor or not. The images system is very important in the Cyberknife equipment because that's where we can verify live that the patient stays in the same position as it was when the simulation of the treatment was made. One of the most used tracking systems is the skull tracking. This is the tracking system for intracranial injuries. The next tracking system is the model with fiducials. The third is the one when we use the spinal cord in a vertebra or near it, and it's called the X-side spine. Another tracking system of this really helpful equipment is the long tracking system. And as its name says, it's used in lung injuries. And the last scan mode that has the radiosurgery system of Cyberknife, it's a hybrid system, because it uses the fiducials in the patient and then it's used in the synchrony tracking system, the same used in lungs. There's some parameters to consider for the quality control, and one of those, and the most important, is that the delivery of the doses has to be in the exact amount and in the exact area where it's wanted. We use radiosurgery and simulations on mannequins or phantoms to actually determine if the doses in the planification system and the way the robot is gonna give it, it's really where and what it wants. Other of the parameters of the quality control, and a really important one in the radiosurgery system of Cyberknife, is the determination of the absorbed doses in the reference condition of the equipment. This is an equipment with a very specific machine that has to keep certain standard pattern at international level to be able to determine the absorbed doses in reference conditions. I'm in charge of the preventive and corrective maintenance of the equipment. This maintenance is given between 6 and 12 months, depending on the faults to solve in the system. For the PC switch, we usually answer in a period of approximately 3 or 5 days. We work jointly with the United States staff in Accurate, and they support us in a remote way through internet or telephone. Also, I work with the physicists of the complex because when it's made any change or modification, they has to verify it, has to be adjusted as it was before, or if there's no need to.
Velmat, we give to the health sector the best quality and innovation in medical equipment. We have the first radiosurgery Cyberknife equipment in Latin America, along with highly trained staff in the area.